we'll talk about some more electrical principles. Ohm's law. Now, this is where you have to do some math. It's division and multiplication. So most everybody shouldn't need a calculator. The ohm is defined as the electrical resistance between 2 points of a conductor when a constant potential difference of 1 volt applied to those points produces in the conductor a current of 1 ampere, the conductor not being the seat of any electromotive force. That's the official Ohm's law definition by Mr. Ohm. The last part, not being the seat of any electromotive force, means there's no battery or other voltage source in there. Okay, so you're really measuring the resistance between 2 points when you apply a voltage. The law is actually written as resistance is equal to the voltage or the potential divided by the current, or E over I. And he actually did this by experimentation. He would take different materials, apply a voltage, measure the current, and do it for different voltages, and plotted it, and it would turn out to be a straight line. And the slope of that line, which is the ratio of voltage to current, is resistance. And like I said before, we use the Greek symbol omega to represent it in a lot of cases. This is just an example of doing the measurements and plotting them. And you see that the slope of that line is R, or the resistance. It's just the ratio of E to I. And it follows, if you remember, there's a first order formula, mx plus b, which I've actually used a lot over the years, which is the plot of a straight line. And b is the intercept, where it intersects the y-axis. In this case, the intersect is 0, so it's equivalent to the resistance times the current. This is an easier way a lot of people use to remember the Ohm's law. We call it a kind of a pie chart, and if you have trouble with it, on the back of the answer sheet, draw your little circle, divide it in half and a quarter, and write your E, I, and R. And the way it works is, if you want to find the voltage, you put your finger over the E, and it says that it's going to be the current times the resistance. If you wanted to find the current, you just put your finger over current, and it's going to be voltage divided by resistance. Likewise, to find R, it's going to be voltage divided by current. So it's a very easy way a lot of people use to remember the formula.
And 60 years ago, we usually represented the current with an A instead of an I. So it was real nice to have here, E equals AR.
Yeah. And here I've just broken the 3 versions of the formula down with some examples where if we had 2 amps and 5 ohms of resistance, it's going to be 10 volts across it. Or if I have 10 volts and 5 amps of resistance, 5 ohms of resistance, it's going to be a current of 2 amps, or 10 volts with 2 amps, it says resistance is going to be 5 ohms. So what formula is used to calculate voltage in a circuit?
A.
Hey.
So E is equal to I times R. After you use it a lot, it just becomes, because you will doing most anything in electronics, you will use Ohm's law. It even applies to your household voltage and current.
I need that circle right here.
What formula is used to calculate resistance in a circuit? Ratio of voltage to current. What formula is used to calculate current in a circuit?
B.
Draw your circle.
Yeah, in my head, I'm thinking A is on the top and R is on the bottom, so it has to be.
You can visualize that circle.
Yeah, visualize, well, that's the only way.
All right.
The first time I didn't visualize the circle.
So current's the ratio of potential to opposition. Or voltage to resistance. Oh, honey. Uh-oh. You sure? 'Cause it doesn't always show up right away.
That's probably why you felt it wobble a lot. Yeah. You all right? That's like, take this.
I told you you should have got the good chair.
Back. So look for the picture.
Okay, sure you're okay?
Yeah.
All right,
The first time must have wobbled, you felt it, you know.
Because-
it wobbled.
because we are at a pharmacy, they,
Yeah, they have a pharmacy here, we'll find.
They might give you some extra drugs.
okay. What is the resistance of a circuit in which a current of 3 amperes flows when connected to a 90-volt source?
B.
What two things do you have, what do you not have?
Very good.
Well, that one was. The other numbers were all wrong. Had to be P, because those,
Well, usually at least 2 of them are very wrong.
yeah,
What is the resistance of a circuit for which the applied voltage is 12 volts? The current is 1.5 amperes. So you know voltage and current, they want to know resistance. Remember, put your finger over the R. What are you left with?
So divided by
E
one point five.
over. then
I.
divided by 1.5.
Right.
And I can't do math in my head, I guess. 'cause-
Eight ohms.
Yeah, I'm guessing.
Well, it's obviously not 18.
Yeah, it's not 18.
So it's either 8 or 13 and a half, right?
Yeah, it's not 13.5, it's gotta be 8.
So what's the resistance? Okay, 8 ohms. What is the resistance of a circuit drawing 4 amps from a 12-volt source? Same problem, different numbers.
Yeah, 3.
Very good. What is the current in a circuit with an applied voltage of 120 volts and a resistance of 80 ohms? So you got voltage and resistance, they want current.
I think in the previous.
E.
Very good.
I couldn't do that now.
Well, you can use your calculator.
I just removed the other ones
Right.
that were ridiculous.
Right. I mean, it's obviously not 9,600
Yeah,
and it's probably not 0.667.
It's 2/3 of,
What is the current through a 100 ohm resistor when connected across 200 volts? So you want I, and you've got R and E. Remember, E is at the top, R is at the bottom. So to find I, that leaves you with what?
2 divided by 1.
C,
C.
C,
So, yeah,
Charlie. What is the current through a 24 ohm resistor when connected across 240 volts?
C,
Any more guesses?
yeah.
Remember, you're
C.
still finding current.
Gotta be C.
That's the only math that makes sense.
Huh?
It's the only math number that makes any sense.
Right.
That's funny.
What is the voltage across a 2 ohm resistor if a current of 0.5 amperes flows through it? So they want voltage, we know resistance, and we know current. So put your finger over the E on the top, and what do you got on the bottom?
A,
Yeah, A.
What is the voltage across a 10 ohm resistor if a current of 1 ampere flows through it? So
B.
different numbers.
B.
What's the voltage across a 10 ohm resistor if a current of 2 amps flows through it?
B.
D,
Okay. Now you notice how many of those questions there were. So the odds of getting one of those is very high. But if you can remember your little pie chart, you shouldn't have any trouble. So we'll talk about series and parallel circuits, and we'll talk about a series circuit where I have, in this case, I've got a voltage source and 2 resistors in series. And one of the things about a series circuit is that the current is the same through all the components in series. There's a Kirchhoff's law about that all the currents into and out of a node add up to 0, which is another way of doing it. But you just need to remember that in a series circuit, the current is going to be the same through all the components. Whereas in a parallel circuit, the voltage is going to be the same across the components. So in this case, we have a current I, which is flowing through those 2 5 ohm resistors. And I worked out that the voltage, the input voltage E is going to be equal to the voltage drop across the 2 resistors, E1 and E2. And if you take the current times R1 and R2, okay, and you actually fill it in, then you will find out that it's 10 volts in that case, because you know that the current has to be the same. So in which type of circuit is DC current the same through all components?
I was gonna say A. So. I'm just gonna say that out loud so I could be wrong.
That's all right. You learn from mistakes. But you're right.
Oh.
The current is the same. And notice they say DC current because this won't necessarily apply if it's alternating current where there's frequency. But we're not there yet. So for a DC current, okay, it's going to be the same through all the elements. So we have a parallel circuit, okay, we have these two resistors connected in parallel instead of series. So the current through each of them can be different. The voltage across them is going to be the same. So if we've got 10 volts source over here, the voltage across R1 is 10 volts and the voltage across R3 over there is 10 volts. But depending on the resistance being different, the currents will be different. So you can see we have 4 amps flowing through R1 because it's 2.5 ohms. So 2.5 into 10 is 4. And R3 is 5 ohms. So 5 into 10 is 2. So we've got 2 amps flowing there. So we have a total of 6 amps flowing because the equivalent resistance of these two in parallel, okay, is going to be less than 2.5 ohms. So it's going to be,
1.33.
right, an odd number. And we'll talk about how you calculate that, I think. You'll do this, you do the reciprocal of the sum of the reciprocals, which sounds a lot more complicated than it is. In which type of circuit is the voltage the same across all components?
B.
B. So series current's the same, parallel voltage is the same. And in a resonant circuit, it's totally different. And a branch, and the only reference I could figure out they were possibly referring to, you can have a branch circuit in your house, like a branch panel. It has absolutely nothing to do with this question. It's just one of those outlier answers just to fill up one of them that's wrong. Sometimes it helps to know why the wrong answers are wrong. Okay, so what we should have learned is Ohm's law, how to draw your little circle, that ohms are units of resistance, that series circuits have the same current through all the components, DC current, and parallel circuits have the same voltage across components, also DC. Because in a resonant series or parallel circuit, these don't hold. And I didn't stop the recording yet.